Alright, let's look at section 8.3, problem number 7. Alright, so we want to find the centroid of this given region. Alright, so let's first draw a picture here. Alright, so we have the x-axis, y-axis here, and here is the x-axis. Alright. Then, so e to the x, so it's an increasing exponential function, and go through 1, so it looks kind of like that. Alright, and then you're going from x equals 0 to x equals 1. So it's going to be somewhere probably around here, 1. Alright, so we have something like that. Alright, so we have this is the region. Alright, let's find the centroid. Alright, so first thing we need is actually the area. So let's go ahead and find area A. It's going to be simply integral starting from 0 to 1. And the graph is e to the x, so e to the x dx. Alright, so this is going to be antiderivative of e to the x is still e to the x, going from 0 to 1. And plugging 1, you get e, and plugging 0, e to 0 is 1. Alright, so that's the area. Alright, then we need to find the moments with respect to y. Alright, so let's find that. Alright, so I'm gonna assume that the density is equal to 1, so that the centroid and the center of mass are exactly the same. Alright, so we have you have an integral from 0 to 1. Alright, so it's a x times f of x, which is e to the x dx. Alright, so this we need to use the integration by parts. Take the derivative of x, you get 1. Take the antiderivative of e to the x, you get e to the x. So first we multiply diagonally. So that's going to get us x times e to the x. And then you're going from 0 to 1 minus integral from 0 to 1. Then we multiply this way. So that's just a e to the x. Right, with respect to x. Right, so if you evaluate that, plugging 1 times e to the 1 is e. And minus plugging 0, so it's minus 0. So I'm not going to write anything down. Right, then you have e to the x, antiderivative still e to the x, going from 0 to 1. So this is going to be e minus plugging 1, e, minus plugging 0, 1. So we have e minus e cancel out, and double negative, so it's going to be positive 1. Alright, so we found moment with respect to y-axis, and also we need to find the moments with respect to x. Alright, so this is going to be 1/2 integral from 0 to 1. Alright, then you have f of x squared, so in this case e to the 2x, right, with respect to x. So this is going to be 1/2. Antiderivative of e to the 2x is e to the 2x over 2. Then you're going from 0 to 1. Alright, I'm going to go ahead and combine this 2. Then I'm going to change that to 4 on the bottom. Then we plug in, so it's 1/4. And plug in 1, so you get e squared minus plug in 0, e to the 0 is 1 again. Alright, so we got the moments with respect to y-axis, alright, x-axis. Alright, so we can find x bar and y bar. Alright, so x bar, so here we're gonna get, alright, x bar. And remember that the moments with respect to y divided by the m, but we can, it's also actually, maybe I shouldn't do that, maybe I'll do, right, x bar is, remember that it's just going to be what we get here, my divided by a. Maybe I should do that. So my is 1, right? Then a, it happens to be e minus 1. So we have that. And y bar is what you get here, 1/4 e squared minus 1 over a is e minus 1. Alright, so we just have to divide these guys by a. Right, so the x bar is simple enough, but y bar can be simplified. Alright, so I'm going to just put the 1/4 like that. Alright, and the bottom you have a e minus 1. And up here you have e minus 1 times e plus 1. Right, then we can cancel those out. Alright, then you get e plus 1 over 4. Alright, so those are the coordinates of the centroid. X bar is 1 over e minus 1, and y bar is e plus 1 over 4. Alright, that's it. I hope that this was clear.